43 through 60 is a great concept check to see if you remember things from first trimester, to see if you understand what an atom is, what it's made out of, meaning protons, neutrons, and electrons, and also the numbers on the periodic table. So if the first one, 43 through 46, is all asking about sodium, let's just think about what sodium is. If I look at the box on the periodic table for sodium, all right, it has an Na, a 23, and 11. Number 23 is the atomic mass. The atomic mass is equal to protons plus neutrons. All right, so we can use that number to find two things if we have. Well, we can either find protons or neutrons given neutrons or protons. All right, then 11 is the number of protons. It will also mean the number of electrons. I'm going to put a little star there. I'm going to put if not an ion. All right, an ion is a charged particle, and if you look up here, that's an ion, and that's an ion. So this number will not tell me the number of electrons, but in the other ones, it will. All right, so let's go ahead and look at number 43. This is not an ion because it has no charge, it's neutral. So the number of electrons has to match the number of protons. That's the atomic number. So I look down here in my square, it's 11. The number of protons has to match also, that's 11. Number of neutrons, remember neutrons here. The atomic mass is 23. I have 11 protons, so I just need to take 23 and subtract 11, and I get 12. All right, the electron configuration, I use the number of electrons to figure that out. I have 11 of them, so I'm just going to write 1s2. I'm going to keep on going until I get to 11. After 1s, we have 2s. There's 2. After 2s, we have 2p, and I can put in 6. And we're at 10, so we have one more to go, and that would be 3s. 1. All right, so that would be the complete whole way to do that first row. All right, if it's Na plus, all right, if it's positive, it has lost an electron. Remember, an electron's negative. If we lose something negative, we will become positive. So if it's lost electrons, it has to be, or one electron, it has to be 10. The number of protons will not be any different. So it's 11, meaning it's the same as it was before. In an ion, the only thing that changes is the electrons. So neutrons must be 12. And if the number of electrons changes, if I have one less, then this will have one less. 1s2, 2s2, 2p, 6. All right. If you look, 50 matches this one also. The one down here, 1s2, 2s2, 2p6. So that tells you right off the bat that 52 has 10 electrons. But if you look, whatever 51 is, it has 12 protons. 12 protons has to be Mg. If I have 12 pluses, 10 minuses, it must be a plus 2. All right, this is an isotope down here. I will leave these to you. I did most of them. This should have been numbered something, so put something in that box, meaning the number of electrons on carbon. Remember, for an isotope, this number gives you the mass instead of the number here on the periodic table. All right, good luck.